Well, hello everybody, and welcome back to another riveting session of linear equations. Today we're going to be talking about understanding linear equations. So we've been using equations to graph lines, and we're in the process of understanding slope and the y-intercept and how those two tell us how to graph our equation. But I want to make sure that we all understand how to get these points and what these points that we have on this line actually mean. So if you remember, the minimum number of points that you need to make any line is just 2. That's what we did before. We would graph our y-intercept, that's 1 point, and then we'd use our slope to count up our rise and over for our run and find another point and then connect them. But what if we're asked for more points? How can we identify whether a point is actually on that line with graphing it or without, and how can we determine more points on that line? So we're going to take a look at that today. So let's take a look at the first example. It says give 5 points that lie on the line described by the equation y equals 2x minus 5. Well, first, let's just start by graphing this. So the first thing I'm going to do is realize that my y-intercept is -5. So I'm going to go down to -5 and plot a point. And then my slope is 2, which means if I were to write that as a fraction, that would be 2 over 1, which means I rise 2 and run 1. So I'm going to rise 2 and run 1. And I'm going to rise 2 and run 1. And I'm going to put a few points on here. Rise 2 and run 1. And we'll do one more. Rise 2 and run 1. And then let me go grab a line. And we'll connect these points and make a nice straight line from that. Okay, so now, after what I just did, I could answer what they just asked me to do. They said give 5 points that lie on the line described by the equation. Well, we have 5 points. 1, 2, 3, 4, 5. Those 5 points are 0, -5. That was my first one. That was my y-intercept. So there's a point. I also had the point 1. It's right here. I went over 1 and down to 3. So that's 1, -3. There's another point on that line. I also have, if I go over 2 and down 1, I have the point 2, -1. I have the point 3, 1. I went over to the right 3, and I went up 1. And then my last point that I plotted was 4, 3. So all of those are good points, and we know that because we found our y-intercept and then we used our slope. So that's a possibility. Now, there is another way you can do that. That is the algebraic way where we focus mostly on using that equation. So remember, our equation is y equals 2x minus 5. Well, if I didn't have this graph here, it would be a lot harder to have done what we just did because you'd have to draw a graph and go through that whole hot mess of stuff. So we don't want to do that. What if I just asked you, give me 5 points, and you just boom, 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 boom. We were just able to spit those out right away. That's what we want to go for. So let's give that a try. Now up here, there are no limitations on what I can put in for x. So I could just choose any random number. I could pick -36 and plug that in for x and then do my order of operations, and that would tell me what y is. We did this already when we talked about functions. It's really just the same thing because this is a linear function. So let's just pick 5 x values and we're going to plug them in. This is where we plug and chug. We plug in a number for x and we chug through the operations to figure out what y equals. So I'm going to put in 0 for x. And you could really choose anything, but I'm just going to go with 0 because 0 is easy. So if I were to plug in 0, I would say y equals 2 times 0 minus 5. And when you do the algebra there, or the arithmetic really, 2 times 0 is 0, minus 5 gives me -5. So I know when x is 0, the y value that goes with it is negative 5. Let's try another. Let's put in 1. 1's nice and easy. Y is equal to 2 times 1 minus 5. That means y will be 2 times 1 is 2. 2 minus 5 gives me negative 3. And I have the point 1, negative 3. Let's throw in a 2. Why not? Let me move this out of the way. So we have y equals 2 times 2 minus 5. 2 times 2 is 4, minus 5 is negative 1. There we go. Let's put in 3. Y equals 2 times 3 minus 5. We know that 2 times 3 is what? 6 is correct. Minus 5 gives us 1. And it asks for 5 values, so let's put in our last value of 4. So I'm going to say y equals 2 times 4 minus 5. Y is equal to, we have 8 right here, minus 5 makes 3. Now, remember, every coordinate is made up of an x value and a y value. So each of these numbers, these pairs of numbers that I have listed here, are in fact, that's right, they are coordinates. This is x comma y. That means this right here, 0, negative 5, x is 0, y is negative 5, that is really the point 0, negative 5. You probably knew that by now, and that's a good thing. This pair right here, 1, negative 3, is the ordered pair, 1, negative 3. 2, negative 1, that's another point. 3, 1 is yet another point, and 4, 3 is another point. And we could go on and list millions of points on this line because, as you know, a line goes on forever. It never ends in either direction. So all of these points, and look at what we just graphed. Notice the connection here. These are the points that we originally started off with from our graph. These are the points that we just plugged and chugged and got. They are the same points. They are all on the line. We would call these solutions to the line because when you plug in these two numbers for x and for y, it will make a true statement. So 0, negative 5 is a point. 1, negative 3, that's a point. 2, negative 1 is a point. 3, 1 is a point. And 4, 3 is a point. And we could list a whole bunch more. All right, so there you go. That's two different ways to look at the same thing. So let's look at this one. Now this one's a little bit different, worded a little bit differently. It says, determine if the point negative 2, 7 is a point on the line described by the equation y equals negative 3x plus 1. Explain your reasoning in the space below. All right, so first thing I want you to do, since I gave the graph, we're going to do it the graphing way first. I want you to pause me and go ahead and graph your line using your slope and your y-intercept. And then come back to me when you are done. Okay, so hopefully you went up to positive 1 and made a point for your y-intercept. And then since your slope is negative 3 or negative 3 over 1, you went down 3, 1, 2, 3, and over 1. And then you could keep doing that, down 3, over 1, and so on. And then you connected your points with a nice line like that. So your graph should hopefully look a whole lot like mine. Let me throw some arrows on the end of this. Okay, now we have our graph. Now let's look. What we want to know is the point negative 2, 7 a point on the line? Well, if we have the graph, we can check and see. Well, I'll just go over to the point negative 2, 7. So I go negative 2 up to 7. And it looks like, from what I can tell here, it sure does look like negative 2, 7 is a point on my line. But the only way to really be sure, we could say, yeah, it is, because we graphed it, and it was, when we went to that point, the line passed through it. Or we can prove algebraically that it does. So let's do that. let's take our equation. We know that we want to know the point, if the point -2, 7 is on that line. Well, -2 is my x value. 7 is my y value. If I plug this number in for x and this number in for y and do my calculations, if I get a true statement, it will be correct and it will be a point on the line. If I don't, then it won't. So let's plug it in. Y is 7. We have -3 times -2, forgot my negative, plus 1. So over on the right-hand side, we have -3 times -2, which is 6. And then we add on the 1, and 6 plus 1 is in fact 7. So that checks out. That means that -2, 7 is a point on the line. Y equals -3x plus 1. And the reason why is because when -2 is plugged in for x and 7 is plugged in for y in the equation, it makes a true statement. And that is all there is to it. Boom! Okay, let's try another one. One more for good measure, and let's see. Okay, determine if the point -4, 6 is a point on the line described by the equation y equals 1/2 x minus 4. Explain your reasoning in the space below. I gave you a graph, and you've got a little space over here, so I want you to do the same thing. First, let's graph it and see if we can determine that from the graph, and then we're going to show it algebraically over here. So I want you to do it both ways to draw your conclusion. So go ahead and pause me and give it a try on your own, and then come back when you're done. All right, so you should have a graph that looks very similar to mine, actually identical to mine, and I put 3 points on here. Now from here, if you have the graph, we can just look. Let's go to the point -4, 6. That means I go left 4, and then I go up 6. That point right there. Is that point on my line? And the answer is no. So if it's not on the graph, then that means it's obviously not a point on the line because the line is not passing through that point. Now, if we don't have the graph and we need to figure it out algebraically instead of drawing ourselves a graph and going through all that rigmarole, then we're going to plug and chug. So let's plug in. X is -4, y is 6. So I'm going to plug those in. 6 for y. I have 1/2 times -4 and then minus 4. So that means that 6 is equal to, well, 1/2 times -4, or what is 1/2 of -4? And that is -2 minus 4. If I do my subtraction over here, remember subtracting is the same as adding its opposite. 2 negatives plus 4 negatives gives me 6 negatives. Compare your numbers. Is 6 equal to -6? And hopefully you're saying, no, it is not. They are not equal to. So that means it is not a point on the line. Because when we plugged in our x and y values, it turned out to be an untrue statement. So based on our algebra work, which we'd want to show, we can conclude that the point -4, 6 is not a point on this line confidently, even without the graph. And that, my friends, is all there is to it. And hopefully you have a little bit better understanding of the world of lines, a magical place. All right, until next time, peace out.